Alright guys, I'm back again in another one. Alright, today we're gonna talk about graphing system of linear equation. A system of linear equation consists two or more equation in the system. So we're gonna focus mainly in linear equation lines, multiple lines in a coordinate grid. So we're gonna graph multiple lines. So when you're graphing a system of linear equation, mainly you are looking if there's a solution or not, if the graph intersect. So most of the time the graph going to intersect at the point which is the solution of the system that will satisfy both or as many equations in this system. All right, so there you go. What can happen? Either the graph will intersect. In this case, you have a solution. You have a solution. Then you will find the x and the y coordinate of that solution. In this case, you will see that this system is consistent and dependent. In this case, the line will have different slope. The line will have different slope. So the other alternative that you will have a system where the slope and the y-intercept are the same for both equations. In this case, you will see that the line will be coinciding. If you grab the first one, the second one will be exactly identical, coinciding, merge in the other one. And when they are coinciding, meaning that you have the same slope, the same y-intercept. In this case, that will be infinitely many solutions. In this case, not mainly you have equation, you have more than an equation. This is an identity. So it will accept as many solutions. Every solution will satisfy that. In this case, you will see the system consistent and dependent. Consistent dependent. Excuse me, the system is consistent dependent. Right? The third option is when the lines do not touch, do not intersect. Now, if two lines do not intersect, you have to assume that they are parallel. In this case, they will have same slope but different y-intercept. Same slope but different y-intercept. In this case, the system will be inconsistent. So we're gonna do, if you, let's continue with more graphing of system of equation. So we have the system here. I'm gonna let this is xy. So I'm gonna let y equal 0, then I solve for x. Right? When I let y equal 0, I will have to move 1 on the other side. So I will have to add 1, so I will have x is equal to 1. So this is my order pair 1, 0. Right? Now, when I let x equal to 0, then I will have to solve for y. If I let x equal 0 in this equation, y will be negative 1. This is my two order pairs that I will have to plot for this one. Right? For the second one, right? I'm gonna let y be 0 and x be 0 and find the intercept. So when I let y equal to 0 here, right? I will have to move 3 on the other side. So I will have 0 equal negative x plus 3. I will have to subtract 3. Subtract 3, I will have negative 3 is equal to negative x divided by negative 1. Then I will have x is 3. All right. When I let x equal to 0, now I will have y is 3. So these are my order pair that I will have to graph. So let me graph the red, the one that in red. So since my interval is not big, so I can use interval of 1. That will be 1, 2, 3. That will be 3, 0. Right? The other one is 0, 3. Then I will go 3 unit up. 0, 3. Then you do this. You connect those two dots, the line. Then you have the equation y equal negative x plus 3. The second one that in green is 1, 0. That will be this point here. That will be that will be 1, 0. The other one is 0, negative 1. Then you go 1 unit down. That's 0, negative 1. Then you connect this, and this telling you this is the solution of the system. This is where that will satisfy both points. And this equation is y equal x minus 1. Right? Then this telling you more or less this is the solution of the system. That's the problem with graphing. This, it doesn't tell you exactly what it is. But if you were using substitution, elimination will tell you exactly where those 2 points touch. You have an equation which is 2x plus y is equal to 4. X minus y is equal to 2. Once again, we're going to do the table of to find the intercept. Let y equal to 0, let x equal to 0. Right? If I go in the first equation, I'll let y equal 0, I will have 2x is equal to 4. 2x is equal to 4 divided by 2. In this case, I will have x is 2. This is my 2, 0. So when I let x equal to 0, I will have y is equal to 4. And this is my, done with this, I find my 2 intersect. Here I come here, right? Do the same thing. When I let y equal to 0, I will have x is equal to 2. When I let x is equal to 0, I will have negative y is equal to 2. And I will have to divide by negative 1. Then this will be my order set of points that I will have to graph. Then you go, and since my are not big, I can use unit of 1, interval of 1. Right, 2, 0, go to unit to the right. That will be 2, 0. 0, 4, go for unit up. Then you connect this. This is the first one. 2x plus y is equal to 4. And for the second one, 2, 0. This is a good one. It tells you exactly 2, 0. That's another one. And 0, negative 2. That's another one. And as you can see, this is telling you where the graph intersect because they have 2, 0 in common. 2, 0 is the intersection where they intersect. 2, 0 is the solution of that system. This you can tell because you can see it from the graph. So. When I come here, let y equal to 0, I will have 2x is equal to 4. 2x is equal to 4. Divide by 2, then you get x is equal to 2. This is your x-intercept to 0. when I come here, let x equal 0, I will have negative 2y is equal to 4 divided by negative 2. Then y is negative 2. That will be your x and y intercept for that. Here, when I come here, I do the same thing. I let my y to be 0. I will have negative x is equal to 6, just divided by negative 1. Then I will have negative 6, 0. So when I let x equal 0, here I will have y is equal to 6. This is how order pairs. So in this case, my largest number is 6, both on the x on the y-axis. On the x-axis is to the left, so I'm counting 6 to the left. That will be my 6 unit, and 6 unit up. You have to be aware of your interval, how to do a graph. 2, 0, 2 unit to the right, that would be 2, 0. And the other one is 0, negative 2, go 2 unit down, that would be 0, negative 2. Then you connect this line. This is your line where you have this equation 2x minus 2y is equal to 4. For this one, I have negative 6, 0, 2, 4, 6, negative 6, negative 6, 0, 6 unit to the left and 6 unit up, 2, 4, 6, that's 0, 6, then you connect them. As you can see, those two equations do not touch. In this case, you will have to look at their slope. They may have the same slope. So if I was to put this in slope-intercept form, I will have to add x on that side and x on that side. I will have y is equal x plus 6. So my m is 1. Same thing. So subtract 2x, you will have negative 2y is equal to negative 2x plus 4 divided by negative 2. Okay? And you will have y is equal to x minus 2. And your m2 is 1. They have same slope but different y-intercept. That the reason they do not touch. Those two lines are parallel. So that's how you will see it. In this case, you will have no solution. The system will be inconsistent. So this is a parallel line. So by putting it in slope-intercept form, you can compare their slope. So in this case, there's no solution. This is not true. No matter how you graph it, you will not find a solution for that system. So be aware of those things. X is equal to negative 3, y is equal to 5. This is an easy one, but that could be trouble for many of you, where you have an horizontal and a vertical line. So in this case, they will be perpendicular. That's technique, that classical definition. You go to the left to a unit. This is negative 3, 0. So this is a vertical line. If you were to find this slope will be undefined. This is a vertical line, and this is y is equal to 5. You go 5 unit up. This is 0, 5, and this is an horizontal line. If you were to find this slope will have been 0. So the solution for this is here, where this is the solution where they touch at negative 3, 5. This is your solution. And this will form a 90-degree angle since they are perpendicular. So be aware of that. If it's horizontal, it's parallel to the x-axis, and this slope is 0 is vertical, is parallel to the y-axis, the slope will be undefined. So this is a special case, special case. Be aware of that. Many students have problem graphing x equal to k. This is a constant vertical. Y equal to k is horizontal. This slope is 0. X equal to k, right? It's a vertical line, but undefined. Y equal to k is horizontal. The slope is 0. So be aware of that classic definition. If you have an horizontal and a vertical line in the same coordinate grid, they will always be perpendicular. So be aware of that. Y minus 3x is equal to 2, and for x minus 12y is equal to 8. Alright, let's try to graph the first one. So before we graph it, so let's see what's going on. Those have 4 in common. You could have simplified that if you wish. You could have simplified that. So if I've simplified that, it will have given me 3x by 4. Simplified by 4, that will give me x minus 3y is equal to 2. Right? You could have done that. So, right, so let's find x, y. Now let y is equal to 0. I will have negative 3x is equal to 2. You'll divide by negative 3. Then my intercept will be negative 3/2 less negative 3/2. It's the other way around. It's negative 2/3. Be careful. So I just made the mistake myself. Right? So when y is 0, you divide both sides by 3, you will have this with x as negative 2/3. So when I let x is equal to 0, then y is 2. So this is my point. Right? I do the same thing again for the second equation. When I let y is equal to 0, I will have for x is equal to 8. For x is equal to 8 divided by 4. In this case, x is 2. But when I let x is equal to 0, now we'll have negative 12y is equal to 8 divided by negative 12. Since they have 4 in common, all right, I will give you negative 2/3. Then we try to plot that. Those are not big. That with numbers, we're going to use interval of 1. All right, negative 2/3. This is 1. All right, this will have to break it into 3 pieces. 1, this will be negative 2/3. Negative 2/3. Right? 0. Right, the other one is 0, 2, go to unit up. 0, 2. Then you connect this with that. That is your line. Right? For y equal negative 3x. Y minus 3x is equal to 2. The second one is 2, 0. 1, 2. That will be 2, 0. And negative 2/3. That will be 1. Right? Break that into 3 pieces. That will be negative 2/3. Negative 2/3. Then you connect them. Let me change my call. Right? You go here. is telling you this is the solution of the system for x minus 12y is equal to 8. And you're done. The only thing you're doing is finding the intercept, x and y-intercept. I did not look for any other points. In this case, if you put it in slope-intercept form, you will see that the slope will be different. They will have different y-intercept. See? You will have y is equal to 3x plus 2 in this case. M1 is 3, B1 is 2. If I go in this, yes, solve for y, I will subtract 4x on the other side. I will have negative 12y is equal to negative 4x minus plus 8 divided by negative 12. And I will have y is equal to 1/3 x minus 2/3. As you can see, they have different slope. The slope are different. If the slope are different, they have to intercept different slope, different y-intercept as a solution. And this is the solution of your system. So you can predict what's going to happen. If you can put your equation slope intercept form and know the rules, what happened. All right. So if I have x minus 3y is, I just grab that. Y is equal to 4. And y minus x is equal to 6. Same thing again. Nothing changed. I let y equal to 0, I'll have 2x is equal to 4, this is 2. So if I come here, right, I let x equal to 0, this will give me negative 2. So this is my two-ordered pair. Same thing here. If I come here, let my y equal 0, I will have negative x is equal to 6 divided by negative 1. This will be negative 6, 0. Right? If I let here, let x, this is 6, 0, 6. Then you go and plot that bad boy. I 2, 0 to unit to the unit to the right. That will be 2, 0. Right? 0, negative 2 to unit down. That is 0, negative 2. And this is our equation. This is the line of the equation, which is 2x minus 2y is equal to 4. The other one goes 6 units to the left. 1, 2, 3, 4, 5, 6. It seems that I grabbed that already. Negative 6, 0. The other one is 6, 0, 6. Go 6, and once again, those lines do not touch. You will have to assume that they are parallel. All right, that's our lesson for today. Let's recap when you're graphing a system of a linear equation. So there are three things that can happen. You can have a solution. If you find a solution, it's because the equation have different slope. They have a different slope, and they will intersect. In this case, your system will be consistent and dependent. Your system will be consistent and dependent. The other alternative, so you could have same slope, same y-intercept. This will call coinciding. A line, a graph, you graph a line on top of another line. It's the same line. In this case, your system will be consistent, dependent. And the third option, that when they have the same slope but different y-intercept, the two lines will be parallel. There will be no solution. No solution, meaning the line will never touch. In this case, the system will be inconsistent. They have the same slope, same slope, same slope. They will not touch. All right, that was Mr. D. Go do your practice. Study, 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 study. Then you're gonna make the grade. All right, peace out. Remember, go to subscribe, like, and share. Bye-bye.